you would like to hit record, Brian Amor, that is. Welcome, everyone. And today we have Brian Werts and Erik Gough. They're from Purdue University. Today they're going to talk to you about a composable solution that they're working on at Purdue University. I'll let them do their introductions. They will handle their questions. I'll let Brian and Erik explain the format they would like in terms of the presentation. With that, we'll go ahead and get started, and thank you for joining us. Erik or Brian? They're like, 1 minute.
Erik's starting, so okay. I don't know if he's muted.
All right, thanks everybody. So I'm Erik Gough, and I'm here with Brian Werts. We're going to tell you about our new Kubernetes-based composable platform that we're deploying at Purdue University. What we'd like to do is have everybody put their questions maybe in the chat, and then we'll have some time to answer those at the end. So let's get started. So I'm going to start by going over a little bit about the motivation and goals behind deploying a private campus cloud. I'm going to make an attempt to define composability and kind of explain how we think this system is going to, where it's going to sit in our research computing offerings. And then Brian, who's the real technical person, is going to go through all the technologies and components that we're using. He'll go through use cases, and then we'll kind of talk about our timeline for deployment and some of the experiences that we've had so far with early access. And if you're curious about the Geddes name, we name each of our resources after Purdue faculty or Purdue alumni that have made some significant impact in their field. This resource is named after Linnell Geddes, and if the slides are shared, you can click that link and get some more information about her impact at the university. And I'll also mention that this work is supported by NSF through the CC Star program. It's a great program to get some resources at your campus to help support science. So if you're not familiar with it, you should check that out. So why are we doing this? At Purdue, we've been doing batch computing for a long time now, and we do that through a community cluster program, which is sort of a reference implementation for a condo HPC model where we build a central resource almost every year, and the faculty and researchers can simply buy a certain number of nodes in that resource. They get access to that and also get access opportunistically to everybody else's nodes in the cluster. And we think this has been extremely successful in meeting the need for that batch HPC work on campus. But what we've seen probably in the last, we've always seen it, I guess, but especially in the past 2 to 3 years is researchers are coming to us and they're increasingly looking for cloud style flexibility. They want to run containers. They might want to run a persistent service like a database that their HPC can interact with. They might want to deploy some container-based data analysis tools, or they might want to deploy an entire web-based science gateway to help drive whatever scientific data analysis need that they have. And the solution here is it really starts to look like a cloud system. And so we ask ourselves, why don't we just push the researcher to the public cloud? There's unlimited resources there. Why aren't we saying, hey, just take your credit card and go have fun on Google or Azure, whatever your choice is? But there are a few problems with that. And first is that it's not leveraging the existing infrastructure investments that we have on campus. Many campuses have high-speed networking, they have large-scale storage systems, large-scale batch systems, and by pushing these researchers to the public cloud, you're kind of eliminating access to those resources. You're also making researchers their own security teams, which there have been some highly publicized data leaks from people who run things in the cloud and they don't properly secure their systems. And this can also be costly for just the new scientist or the naive scientist who doesn't really understand how cloud computing works, where they might leave some instance up for a long time, or they aren't sure how the networking works when you put data in and how it costs to pull data out. So you can really get a big bill if you're not wise about how you're using public cloud. So what we're really trying to do is kind of create this path from the local researcher to some private campus cloud solution where they can then, if they exceed the resources that are available to them there, they can then shift to public cloud or some national resource like Jetstream. So here are our goals, and what we're really trying to do is create a campus ecosystem for cloud technologies, similar to how we have an ecosystem for batch resources. And if we look through, if we look out to labs and research groups on campus, we see that they're already using containers on their laptops or containers on their lab workstations, and they're using virtualization as well. And we really want to not just create this ecosystem and present some technology to the user. We're really trying to make sure that we have ample documentation. We're running workshops, so we're doing knowledge sharing and support throughout the campus. We want to empower faculty to integrate these cloud computing technologies. And this isn't only for research, it's also for instruction. So if you could think, maybe you have a data science class that has 150 students and they all need access to a notebook and some sort of database. We want to be able to provide a platform that can meet that need. And it's something that these the faculty or graduate students can do on their own. We also want to get people familiar with what we call these DevOps methodologies, where you have version control, automation, continuous integration, and allowing these research groups to make reproducible and shareable science. You can think that there's a lot of opportunity with containers to reduce that time to science in a research lab, where when a new graduate student joins, their first task isn't learning how Python packaging works and all the pitfalls there. It's really just, hey, our lab has this container. This contains all of our code and algorithms, and you can use this to get started on your research. So this system is really a complement to the community cluster program. And the same way that the community cluster program is sustainable, and we've proved that we can do this year after year, we want to make sure that we can take this community cloud system and have it be sustainable throughout its lifetime. And another important point is that at Purdue, we're always about developing cyber infrastructure workforce, CI professionals, CI facilitators. So undergraduate students are actively involved in the deployment of this resource. Brian, who is going to give the technical portion of this presentation, he was a student on a CI/CI grant a couple years ago. He's been hired as a full-time employee, and we also have two additional students that are working on this project. And they're really getting tasks that would be designed for an associate level person. So we're really giving him a big chunk of the project to work on. It's not just some low-level tasks that the students are getting. And what we find is that we're typically delighted in the performance of the students that we've had. So what is a composable platform? I use that term a few times. We're we're basically saying that this is a platform for SIOPs. And there's your buzzword for today if you haven't heard it yet. The way we're defining that is DevOps principles that are applied for computational and data intensive science. And there's a link down there to some slides where this term has kind of really gained a lot of traction. So a composable infrastructure is really just a highly customizable pool of resources, CPUs, GPUs, memory, disk, and the people that can use those are allowed to deploy their infrastructure as code. You know, a simple YAML file will get you the infrastructure you need to do whatever science you need to do. We're also giving people opportunity to do version control, automation, portability, and reproducibility. You can kind of see the traditional model for software development here, and then the DevOps model. The only thing that I maybe will say about this is that if anybody on the call has ever run a customer facing VM infrastructure, you probably existed in this traditional model where the developer comes to you and your engineering team deploys some system. You retain root access. You might only give them read access to a directory where they can put their code. You're deploying whatever services they need, if it's a LAMP stack or whatever. And there's always this communication back and forth because the developers don't have full access to the system, and you're basically playing ping pong back and forth several times to get something accomplished that could be relatively simple, like even just like a version upgrade for a package. And you know, this wall in between the two it's probably your ticketing system. We have footprints at Purdue, so it's every time you go back and forth, it's probably through a ticket, and it really just takes a long time to get anything accomplished. We want to get this model going where you have some sort of continuous integration and continuous feedback loop where the developers really have the power to deploy the containers. They have root access in those containers. They can do what they need to do to get their science done in a reasonable time frame. So here's the vision for SIOPs with the Geddes platform. You can see that it's a circular process where researchers have some idea. The way they package their software is through a container using Docker. They upload that to a registry. This can be public or private, and there are several options available that Brian will go through. Then they deploy it on the system, which we use Kubernetes for container orchestration. And on top of that is a Rancher Kubernetes management user interface. It's a web-based user interface. Then they can get feedback from the Rancher interface through the monitoring system there and make any changes they need to the platform that they've deployed. And the important thing here is that, you know, there's not a stopping point here where they have to talk to some engineer to approve a change or get a change made. It's all in their hands, and if they have a problem, they can definitely reach out to our support staff to get help there. But we're not part of the process at every step. So I'm going to turn it over to Brian, and he'll let everyone know about the technical side of the platform.
Yep, let me get set up here. Share screen. You want to stop sharing your screen real quick? Oh, this will force stop. Okay.
Hey, Eric, do you have the slides somewhere we can share them?
I can give you that.
Okay.
All right, does everything look good? All right. So I'm going to go over the more technical aspects of the components of the Geddes system, and this is really starting off with the major or the main components of the Geddes system. So we are using Docker, and Eric kind of gave a good overview of what if you don't know what Docker is, the capabilities of Docker, but the whole concept is, build, share, run, or build, ship, run, and share your applications, and kind of build once, deploy anywhere type of mentality. So we are using Docker as the container runtime. Registries, we are offering both public and private options for registries. So, if users are already utilizing public images or have public images built somewhere that they're utilizing, they'll still have absolute access to those. But they'll also have access to private options through something called Harbor. So if if a user has some type of sensitive or proprietary data in their images they don't want publicly accessible or being able to be pulled, those options are available to them. And these are all easily integrated with CI/CD pipelines, either self-deployed by the users themselves or through something called Rancher that I'll get into more on this slide, actually. So Kubernetes. So Kubernetes is the main orchestration platform that we're using for the Docker containers. And with Kubernetes, we get a really powerful thing called software-defined networking that we're able to leverage to have users, give the users the ability to kind of automatically deploy services directly to multiple different type of networks. So they'll be able to deploy their services directly to the internal private network of the Geddes system, campus private networks, or directly to the public internet itself through public addressing. And with that, with leveraging something called Metal LB as well, be able to access their applications through the standard ports, through the default ports of their services. So down here, we're kind of giving an example of, your db.geddes.archive.purdue.edu. This is really something that is completely automated within the Geddes system, the DNS allocation, and the SSL if you need it as well to be published. So, and then all of your APIs can be published, and your web services are really easy to do with the internal ingress system of Geddes as well. So moving on, the added benefits of Kubernetes, you get the auto scaling. So auto scaling can be set up to, if your applications are getting users' applications are getting hammered, they scale upwards depending on for the need, and back down when they don't need it. Failover and HA capabilities of Kubernetes is greatly beneficial to where, if you have a node that goes down and a user's application is on it, it just migrates to another node, and the storage and the networking that it's utilizing just kind of goes along with it. So for the user's perspective, it's kind of just, if you have a node go down, it's kind of just a blip for the most part. And for Kubernetes also gives us the monitoring and learning that we need as well. And the last major component of the Geddes system is something called Rancher. And Rancher really is the web-based UI into the Kubernetes cluster itself. And with Rancher comes along some unique features that give us finer grain access for finer grain capabilities for authentication and access control. So Rancher introduces something called projects that I'll go over into more detail later. But if you're familiar with Kubernetes namespaces, a Rancher project is simply just a higher level namespace that you can use to kind of determine finer grain access control for users. Development or deployment in Rancher. So you can deploy, users can deploy and manage applications the same way they would do in Kubernetes through the command line. You don't lose any functionality. So it can really be as complicated or easy as you need it to be for the users, or for the users themselves to be able to leverage certain things. Rancher also gives us another layer of monitoring and specifically more visualization into what our cluster is doing. So Grafana is integrated directly into the Rancher UI, so we can get real-time statistics on resource utilization of our cluster. And on the user side as well, they'll have specific Grafana graphs that specify resource utilization for their specific application. So if they're doing any type of if they're having any issues, they can look at what's the utilization, or if they're trying to do any type of fine tuning, they can use those graphs as accordingly. Moving on to the physical architecture of Geddes. On the compute side, we are using Dell, and we're leveraging the same type of technology that we're using for our Bell servers, or our Bell supercomputer here at Purdue, with the AMD 7662 CPUs that utilize direct to the CPU liquid cooling architecture. So a subset of those nodes will also have NVIDIA A100 GPUs available to them, and we picked this specific lineup specifically for the feature that they come with, to where you can take a single GPU and segment it into multiple virtual instances of a GPU. So we can kind of get GPU into the hands of actual users more readily. So, and this kind of negates the scenario where, you know, you might have a user hogging a GPU and only using 10-20% of that GPU. We can kind of take that unused portion in that instance and kind of segment it and get it into the hands of the people who actually want to use it. So that's an exciting feature that I'm really excited for. So storage. We are utilizing Ceph as the backend storage solution for Kubernetes. And within Ceph, we'll have multiple different type of storage types, and then we'll have multiple different types of drive availability tiers or disk tiers for within those different types of storage that I'll go into more detail in the next slide. But right off the bat, we will offer through Ceph file system storage, block storage, and object gateway storage, which will be compatible with S3 directly. So, and with Ceph, we get all the replication, resiliency, and snapshot capabilities of our storage as well. Software-defined networking. In the Geddes system, this is really what enables us to be able to give the users auto provisioning to certain address spaces, like I mentioned, internal private networks, campus networks, or publicly. And I believe the specific container network interfaces that we're using is called Canal, and it kind of leverages things like Flannel and Calico directly for the BGP and the layer 3 and the layer 2 aspects of this. Community cluster integration. Now, this isn't something that's set in stone. We're still doing a lot of investigation on whether or not this is possible, and definitely something we have planned for the late future. But the entire idea behind this would be, we would be able to take unused compute or idle compute in another cluster and kind of dynamically be able to add it to the Geddes platform temporarily for users to burst to if the resource is needed, and then be able to add that resource back to its original cluster. So again, this isn't something that's set in stone. We're still investigating, and hopefully we can keep it on the plate to have planned later on down the line. Storage options. So like I said, we'll have multiple tiers per type of storage. So regarding the table down below, we have block storage that will have an NVMe tier, and this is your high IOPS tier for users that have large databases, machine learning applications that they're deploying, or anything that really needs the high IOPS capability. This tier will be available to them. We have a mid-tier SATA tier that is just your normal general purpose work tier that'll be available for users. And spinning disk tier that is just your large capacity mass storage solution for users as well. For the object storage and the file system storage, we are only offering the NVMe and spinning disk tiers, so those will be available as well for users. Storage in Geddes can really be thought of either as persistent or ephemeral, if I'm pronouncing that right. I practice it. I don't know if I'm saying it right, but you can think of ephemeral as temp space. So it's there when you need it. It's not there when you don't need it. It doesn't persist, but persistent data is also available. Access to data stored on site-wide project storage is also available, and cluster scratch as well will be available for users in this particular system. Security. So security has been a top priority. And security itself is pretty complicated in a multi-tenant situation. But when you start adding, cloud solutions on top of that, it becomes a little bit more of a monster that we've had to pay a lot more attention to. So security has been absolutely a top priority for us. This system will be integrated with campus's single sign-on, and there will be a huge emphasis on role-based access control, and really Rancher really gives us the ability for this through its Rancher projects that I mentioned earlier. Rancher projects gives us the ability to assign ownership to a project that's completely isolated from other projects, and that user in itself could assign users that have special permissions individually through a specific user or groups. So user A might have access to only a single namespace within that project, or all of the namespaces in that project, but they can't manipulate anything within those already deployed namespaces. Or maybe they don't have access to secrets, or or maybe they have full access. It really depends. And the whole idea behind this is the research group or the lab managers that we give ownership to these projects would manage all of that for their users, and we would really only step in if we're absolutely needed to or asked to. Like Erik was mentioning earlier, kind of just like the entire dependency of them doing things on their own is really what we're going for. We're also able to provide something called project level network isolation. And really this is enabled both through the software-defined networking and through Rancher projects themselves. So the whole idea behind this is, anything that's deployed in Project A, for instance, would not be able to communicate or manipulate pods in Project B. So there's a complete isolation there, but this is really lenient on, whether or not how users actually deploy their applications. Obviously, if users are deploying their applications to the campus networks or entirely public on the internet, and then there's not going to be that isolation there. But we see scenarios where, or we can foresee scenarios where a research group might not be ready to go public with their deployments, and they're they're still getting them ready. They're still getting them integrated with everything, and they need them private. And this kind of gives them a scenario where they don't have to worry about anybody stepping on their deployments, breaching any type of data, or keeping it completely secure and isolated from other things until they're absolutely ready to get that out on the public internet or the campus networks. We're also offering container level security scanning. So, and we can do this through a number of different ways, but I think right now we're going to be doing it through something called Harbor. And this is really just give us the ability to periodically scan containers and make sure that there's no specific vulnerability for versioning or specific vulnerabilities that come out. And if there is, we can always get with those particular users to ensure that those applications or those images get updated as well. So the Geddes system itself will be monitored directly by our research computing IDS system that's already been built and has been utilizing now for almost 2 years. This IDS system leverages both Elasticsearch and Kibana for the visualization into this data. So we can create pretty powerful dashboards specifically for the Geddes system to kind of proactively react to things that we might see on the network that is a security risk, or if anything's reported to us from other users that we can use pretty intuitively to get a good eyes on what's happening on the network. So that will be available for the Geddes system when that's launched. So the Rancher UI itself. So if you're unfamiliar with Rancher, you've never seen Rancher before, this is a good example of the visualization through the Grafana graphs that you'll get for your cluster. So here we have specific CPU, memory, and overall pod utilization of the cluster. Really basic overview of how your internal Kubernetes services are doing. Green good, red bad type of scenario. And with the gray boxes down below too, those are drop downs to where additional real-time Grafana graphs will be presented, to where it'll show direct CPU utilization, IO utilization, network utilization, and so forth, to get a finer grain idea of what's actually going on with the cluster itself. And this is similar to a particular view that a direct user would have for their self-deployed application. There'll be a drop-down for metrics for their application. So if they deploy a database, they'll be able to see, like I just said, CPU, IO, network utilization, and kind of get an idea how their applications are doing. At the bottom right here, I think I forgot to mention this earlier, but Rancher also comes along with its own kind of special feature called Rancher catalogs. And Rancher catalog is simply just a Helm chart that Rancher uses like one additional metadata file to be able to present a really basic form for a user to click through and answer basic questions for to be able to deploy their application. So there's a MySQL Rancher catalog here, and all a user would have to do is click on that, answer some really basic questions. what do you want your database name to be? What do you want your admin's username to be? Do you want persistent storage? And then simply from there, they would just click launch. And then you'd have a database within 5 minutes. And that really, user doesn't have to walk into this knowing anything about Kubernetes or really knowing anything about MySQL. And in 5 minutes, they'll have, they'll be able to launch their own database and have access to it, root access to it. This is a quick overview of kind of the project level and the namespace level isolation or separation that we have in Rancher. So at the top here, we have a default project with 4 namespaces and a second name or a project called Dwight, which is actually one of the other coworkers that were working on the project here and figuring out all the Harbor registry stuff. So if Dwight, for example, wasn't an admin and he was just a simple user that was assigned ownership of this project, anything that he does in that project is completely isolated. He doesn't have to worry about stepping on anybody else's toes, stepping on anybody else's, or accidentally accessing anybody else's secrets, or anything like that. And he doesn't have to worry about the same thing. It's completely isolated from other projects. He kind of just has his own playground. And this is another example of the Rancher UI. This is something a user would typically see in their own project. So here we have an RCAC demo project with 2 namespaces that we deployed a Jupyter Hub instance and MySQL database to. And this is really what a user would typically see and be able to navigate through all of this. And it can, like I said, you can import direct YAML or use the GUI itself to deploy your applications. And like I said, it can be really as difficult or as easy as the user requires for their particular use cases. So applications use cases. So what's a good use case for Geddes? That last slide there was a perfect example of something that is a good use case for Geddes. So if you have the need to deploy a lot of notebooks, a lot of databases, any type of data analytic tool, those are perfect use cases for Geddes. Any type of user-facing web services. Right now we have active use cases in our alpha deployment of Geddes for early access users that are using our Shiny deployments and just basic Nginx web services. Those are really easy to use and get started with all the automation between SSL and DNS within the Geddes system to get up and running. Any type of scale-out batch processes and distributed processing pipelines. So we also have a use case for a customer that's using Jupyter Hub and specifically PySpark notebooks to use to deploy Spark workers across the Kubernetes cluster, and it's actually using Kubernetes as the Spark master. So that's an awesome use case for something distributed pipeline or processing pipeline associated stuff. Data streaming. So, Kafka is really popular, KSQL, integrating Elasticsearch and Kibana, those type of things. Those are awesome use cases for Geddes, and actually something that we have up and running right now in our alpha deployment as well, that we gave ownership, project ownership to somebody within the data mine here at Purdue. And this person walked in with little to no Kubernetes experience and was able to have a Kafka instance that was scalable with zookeepers and a KSQL and Postgres instance up that he was actually interacting with through a Docker container on his home laptop. So these are perfect examples of something that's doable and really easy to do within the Geddes system. And really any type of persistent application. So you're not limited by the wall time of your queue here. Anything that you really need to be persistent over time would be a good use case for Geddes. So what's not a good use case for Geddes? HPC in general. If your applications or user applications are dependent on the high speed, low latency interconnects of say InfiniBand, it's not a good use case. And typically, if that person does have a use case for that, they have access to some type of community resource or HPC cluster to do those particular workloads on. Science gateways. So science gateways are really popular, and is another great example of something that's a good use case for Geddes. Specifically here that we have up and running right now in our alpha deployment is through the Wisecaver Labs, their Co-Explorer application. So this is already deployed out onto the public internet where people can access it and play around with it. And here they can actually go to the application, they can query data through it, create custom, not custom, but select a particular type of graphing that you want for the data. And at the top right here, there's an example where you can actually download the data directly from this application. And this is all, everything that's done through here was maybe a 15-minute process. And that was even with doing some things manually since it was the alpha deployment at the time. But that just showcases how quick and easy some of these things are to get up and running. In the Geddes timeline, I think I'm going to pass it back over to Erik for this one.
Cool, thanks. You can just leave it up. That's fine.
Oh, leave it up. All right.
Thanks, Brian. Yeah, so any of the images that you saw in the presentation were from our alpha proof of concept that has been up for several months now. I guess we've been working on that. We do plan to have a beta release of this system sometime in the next couple months. This is where we do a hardware refresh, add the GPUs, and then deploy some additional Kubernetes components that allow for additional automation of the processes. We plan to have early users on the system this spring and early summer, and then fingers crossed, full production sometime in July. And throughout the past couple of months, we've been adding new users from different places. We've been having discussions with people from NanoHub to deploy science gateways similar to that. And we've also been in communication with professors for doing courses on this system, not in the spring semester, but next fall. And one of the final goals is to develop a campus cost model for this. And the cost model for our community cluster program is really pretty simple. You buy a node. There's a one-time cost. You get access to that node for the lifetime of the cluster, which is typically 5 to 6 years. For a cloud resource, we're not quite sure what that looks like yet. Is it that you buy a node and you get access to the resources that would be associated with that node for a period of time? Or is it that we get kind of down into these cloud type pricing models where you're paying per CPU or memory? And honestly, that seems really complicated. But we're going to look at it to see which makes the most sense for this to be a sustainable system. And the final comment that I'll make is that we will be integrating these capabilities with our Anvil system, which is our the new Exceed capacity system that we're deploying here at Purdue. That will be online in October of this year, and you can expect full integration between that system and a similar Kubernetes composable system. So with that, I would say, Brian, next slide. Thanks to everyone for attending the presentation and hearing us talk. We want to thank our early access users who have deployed some of the things that you've seen in the presentation. And there you can see the Geddes team, PIs, and again, would like to thank NSF for the award to help support this project. So with that, I think we'll go ahead and take any questions.
Erik, I just want to swing back through to make sure these questions have been answered in the question section of the Google Doc. We have may get addressed soon, but what software is used for security scanning containers? I think, Brian, you answered that.
That's the Harbor Registry provides that functionality.
Is Harbor also hosted on Kubernetes cluster?
Yes.
Okay, and then we did have the question, is Rancher homegrown? But Sam, one of the students posted it is open source, and I think he put the link to that. And then how is resource contention handled? Do researchers have their own areas, or does it work similar to an HPC scheduler? I'm not sure if you answered that question.
Maybe we didn't. You can get assigned a certain set of resources in Rancher, and then you're limited to what is defined for your particular project. And I guess you just trust the C groups handles that.
So one other question we had is, why not use OpenStack?
That's a great question. So we do have virtualization functionality now on all of our HPC resources. So if you need to use, if you need to run a virtual machine, I'll take Windows, a Windows VM, for instance. Say you need to run Windows for whatever reason. Virtualization is enabled on all of our HPC nodes through KVM, and you can deploy your, you can reserve a node, and you can deploy your virtual machine on that node. That really doesn't solve a problem if you want to run some sort of persistent virtual machine, but we really think that Kubernetes and containers should be able to meet the demand that we have for running this kind of service. So I guess the answer is virtualization is available if you want to run VMs, and we think we can satisfy the rest with this Rancher and Kubernetes instance.
How are you planning on integrating Nonstuff project storage from HPC environments?
That's a great question. So from a security standpoint, we have deployed this particular system outside outside anything we would consider to be a trusted network for our research computing resources. So the subnet that this is on basically has the same amount of trust that your laptop would have if it were on the Purdue wireless system. So we do want to make sure that people can get access to their data that exists on, say, our central storage resources or Scratch file systems. Our guidance on that right now is that people should focus on protocols that provide proper authentication. So Samba, username and password, SSH, either through username and password or keys. What we don't have is any access to any of our NFS file shares through Geddes, and it's that way now. We are investigating. There's potential that you can provide this access if you're smart about how you're configuring the admissions controller. You can maybe limit access to NFS shares that way, but for now we're just saying that no NFS access, and please use some protocol that is properly authenticated, not just host-based authentication.
So I think we still have a couple more. I don't know if you've answered this. How do you secure the exposed URLs for applications like Jupyter Hub? You may have answered that one.
Maybe, but when you, I'm not sure exactly what this person means, but once you've put your Jupyter Hub on somewhere outside the Kubernetes internal network address space, then it's available, and it can be accessed either if you deployed it on the internal private campus network, then it's accessible on campus. If you've chosen to grab a public load balance IP, then it's available on the internet. And what we are making sure that we do when we explain these concepts to users, we're telling them exactly what that means. So you are on the public internet. People will start scanning you. People can access the thing that you've put there, and make sure you've done the needful to make sure that's a secure deployment.
So one other question, do you provide a playground environment for users to build Docker containers on your system?
That's another great question. And this is something that's been in my mind the past few weeks, because now we're really putting it on the user to have Docker installed somewhere. We don't have a login node or a front end that provides access to the Docker daemon and allows people to access that. And the question is, you know, what sort of risk do we put ourselves at if we do that? Is it enough to let them just play inside the Kubernetes infrastructure? And I don't know. That's a great question.
There was one other one in the chat. Is there a concern about breaking out of Docker containers with escalated privileges onto the Docker host system?
Yeah, there is a concern there, which is why we've deployed this system sort of outside any trusted space. You just have to hope that the vulnerabilities that any of the vulnerabilities that could be exploited in that way are hard to exploit, or we've patched those immediately when they've come out. So that is a risk, and it's something that's on our minds.
There's one typing at the moment, controlled by RBA, CSSO. What credentials are used inside containers? Do they run as root? That's a good question.
They do. You can run a container as root. Yes. It's your choice, I guess. You can either run as root or run as some other UID.
And have you looked at Kubeflow? If so, thoughts?
I have not. Brian, have you?
Whoa. Someone,
No, I have not.
Billy Barnett has stumped you. I'm taking that one down.
Good job, Billy.
Yeah, and then why not use Singularity containers?
That's another good question. So we have Singularity on all of our HPC systems, and we do have a lot of usage of Singularity for people that want to run containers for these batch processes. And the reason that we're using Docker in this particular system is that we want to give people access to those, doing things like opening up a port below 10,000, or things that you can't do in Singularity because you're running as your user, as opposed to something that has capabilities that would normally be associated with root.
We had a general question. We will be providing the Zoom link, a recorded copy of this. So yeah, Brian posted that. Okay. I don't see any additional questions. I'm going to pause a second to see if I missed a question. If you had a question and I missed it, please unmute and you can ask, or put it in the question section. Okay, I don't think I'm seeing any additional ones. Want to do a little bit of housekeeping as Brian, oh, we have one. Are the slides available somewhere? We will, I was just going to mention that. So a little bit of housekeeping. We will be providing the slides. Brian and Erik will get those to me, and we'll get them in a place and put them inside the Google Doc, a link to that, so you can get to them. And then for next month, I wanted to make sure I did a shout out, enabling science collaboration with secure and flexible service deployment. This will be done by Rob Gardner of University of Chicago. We hope everyone would please join us. Again, that will be the third Thursday of the month. And as always, if you have suggestions for topics, we did take the topics from last month, and we are starting to vet those and see how they fit in with our overall schedule for the year. So we do continue to do that, but we encourage you to suggest topics for us. Let's see, someone is a Boilermaker. We love Boilermakers. Any additional questions before we call it a day?
I added one in chat and on the doc. I apologize. I had signal issues for a little bit. Don't know if it was covered, but it was about the documentation, about the unique aspects of this.
Okay, so have you been drafting user documentation on how to leverage the unique aspects of this system? I imagine there are opportunities to collaborate across institutions to contribute to documents helping explain these workflows. James, I absolutely love that, and we're always looking for opportunities. Erik or Brian, do you want to comment on that?
Yes, I think that I think many campuses are probably deploying something that's very similar to this, using container technologies. And yeah, if we can leverage each other's efforts to produce great documentation, then that's a big win. So we do have we're doing our internal documentation now. That will eventually make it to our website. But throughout that process, if anybody wants to work on that together, please feel free to email me or Betsy, or and
Absolutely.
we can try to work that out, because that's a great idea.
Yeah, it always makes us better when we can collaborate with other people and get other ideas. I really encourage people, if you're interested, to reach out to Erik, Brian, or myself. We'd love to hear from you. Any last questions that I might have missed? Okay, Brian, I don't know if again, I'd like to mention next month we have Enabling Science Collaboration with Secure and Flexible Service Deployment from Rob Gardner, University of Chicago. We really hope that everyone joins us. And with that, we will make sure the presentation gets posted and the recording is available. Any last messages, Brian or Troy, before we convene?
Thanks for the effort in the presentation. Thanks everybody for attending.
Thank you, everyone. Have a great day.